The aorta is the main blood vessel that leaves the heart, and it works in conjunction with the heart to distribute blood around the body. 150 to 200,000 people die each year from aortic disease, which is more than breast cancer, pancreatic cancer, bowel cancer. We look only at the aorta as a sort of a 2D, non-functional pipe because that's the only tools that are available to us at the moment. What the virtual aorta is going to do is help us to bring biomechanical factors into day-to-day clinical practice.
At the Insight SFI Research Centre for Data Analytics, we perform high-impact, world-class research to enable our society and our citizens and our industry to make better decisions. We're bringing together expertise in all the different areas in AI and data.
What you have is very large files, hundreds of gigabytes for like a full CT scan perhaps.
If we want to look at things like pulse wave velocity, shear stresses, all of those are biomechanical properties of the aorta, it takes about 150 hours in a supercomputer.
What we were looking to do is emulate that process to make a surrogate model essentially, run through AWS in real time in order to reduce that down to perhaps 30 seconds.
One of the challenges that we have is in the area of skills. So our partnership in OCRA funding, Rackspace Technologies and AWS has given us access to skills and to trainings to ensure that our data scientists and our data engineers are appropriately skilled and can work with our industrial partners and our societal partners.
The relationship with Rackspace has been fantastic. Rackspace has been offering kind of the formal training that we would be looking at, so specifically around architecting proper frameworks for such a project like this.
Rackspace has been very influential and very helpful in helping us onboard AWS technologies. We see it as being an important part of the portfolio of infrastructure that we have. What I think is very interesting for us is to figure out how can we move forward to be able to validate those technologies within a clinical setting and to understand what's the future potential for AI to be able to improve the clinical practice of vascular surgeons.
We're taking existing banks of data and turning them into something powerful. And I suppose that's really good about working with Rackspace and working with the cloud solutions is you can also utilise CT scans from around the world.
Scalability is a key aspect of this. To be able to do kind of bespoke experiments around computational modelling, to be able to scale them up and scale them down, that's extremely important.
There were days when we'd have to put stuff onto CDs and get on planes and go over, and now that is so easy and so seamless.
Existing security services within AWS allow us to do this very quickly and to know that it's also secure. Cloud services are very flexible when approaching the question of large data size. You can store it in deep storage, Glacier, and that goes hand in hand with the ability to scale up those experiments. If I look at 12 months down the line, we're really looking at providing as much data as possible for somebody like Niamh to make decisions as effectively as they can in a real-time situation. And it's very achievable because we have the ability to consume lots of data.
To automate our case planning within the first 12 months would be a really good outcome from here. To be able to speed up that process would mean a lot. And I think beyond that is not just helping us treat, but it's helping us understand so that in future we can build better treatments.